So good morning students, now it's time we do exercise 6.5 example sums and exercise sums, some exercise sums in this video. So let's see, this is the example number 2 and the question goes like this. In this figure, AD is perpendicular to BC. Prove that AB square plus BC square CD square is equal to BD square plus AC square. Okay, here in this exercise, to solve any kind of question, we have only one thing in our hand, that is Pythagoras theorem. So all we need to do is find where is right angle triangle and apply Pythagoras theorem. Here D is angle D is 90, so automatically this side of angle D, that is B is also 90 degrees. So in these two triangles we are going to apply Pythagoras theorem. So let's apply in this triangle and then this triangle. In triangle 1, if you do, what the side opposite to right angle will be the hypotenuse. So let's take that AC square is equal to AD square plus DC square. And similarly, if you come to this triangle, the side opposite to right angle BA, so AB square is equal to, what are the other two sides? BD and AD square plus BD square. So now let us see what is being asked. You have to find AB square plus CD square. So you have to, here AB square you already have, here you make CD square is equal to AC square minus AD square. From this equation we can write this. So we need, what we need is AB square plus CD square we need. So let's write AB square plus ये वाला CD square is equal to, दोनों का वैल्यूज लिख दीजिए, AD square plus BD square plus AC plus this one AC square minus AD square. So minus AD square plus AD square cancel, BD square plus AC square, that is what we are asked to prove. So in exercise 6.5, all we have to do is to apply Pythagoras theorem in right angle triangle. Now coming to next proof, that is BL and CM are medians. So BL is median and CM is also median. Median means these two sides will, these two parts will be equal and these two parts will be equal. Let's write that in BM is equal to AM and here CL is equal to AL, or in simple terms CL is equal to, similarly we can write BM is equal to, okay, we will write whatever we need, we will write in a later position. Now let's start doing our sum. Now what is being asked? We are asked to prove 4 into BL square. Okay, whatever we need to prove, we will prove, no problem. But first let us, in this triangle, in this chapter, as I said, wherever we find a right angle triangle, we will keep applying our Pythagoras theorem. All this exercise is basically to give you practice in that. So here angle, there are three triangles here, that is BCA, BLM, BLA, MCA. So let's take all the three triangles and apply. The first triangle being, let's take the bigger triangle ABC. Here we are not having this ABC triangle use at all. So let's take BLA, triangle BAL, and another triangle where MCA. So here in this triangle, what is the side opposite to right angle BAL? In BAL, right angle opposite side is BL. So BL square is equal to AL square plus AB square. Similarly in MCA triangle, angle A is right angle, so the side opposite to angle A is MC. So MC square is equal to CA square plus AM square. So here in MAC, MC square is equal to AC square plus AM square. So here we need BL square, here we need BL square plus CM square. CM square we need. Okay, but answer should only be in BC, no other term is allowed. So let us see what we can do. AL square, AL is half of AC. So let's write that AL is half of AC whole square. Similarly here MC square is equal to AC, okay, AM is half of AB. So once we simplify this, BL square is equal to AC square by 4 plus AB square. MC square is equal to AC square plus AB square by 4. Now multiply throughout with 4. It becomes 4BL square. 4 into AC square by 4. 4 cancels AC square. 4 into AB square, 4AB square. Here also multiply throughout with 4. 4 into MC square, 4MC square. 4 into AC square, 4AC square. 4 into AB square by 4, AB square. Now we have our answer. 4BL square plus 4MC square is equal to AC square plus 4AB square plus 4AC square plus AB square, which is AC plus 4AC 5AC square plus 4AB square, AB square, 5AB square. If you take 5 as common, AC square plus AB square. Now moving back to our question, in our triangle AC square plus AB square is BC square, because this big triangle is also right angle triangle. So here in this place we can write 5 into BC square. So this is the proof, very easy one, you can see in the textbook. Now coming to example number 10, here triangle ACB, angle ACB is equal to 90 degrees. This one is 90 degrees, and we again have this CD is perpendicular to AB. There is a line which is perpendicular to AB. Prove that BC square by AC square is equal to BD by AD. Okay, here these kind of questions are very common and frequently asked in our board examinations. So okay, so let's see. As we have already during Pythagoras theorem proof, we have already proved, if there is any line like this perpendicular and it makes triangle into two parts, these two parts are similar to the bigger part. So here we are taking one of the two parts, that is ACD we will take, and it is similar to ABC, because both are right angle triangles and one common angle always will be there. So let's take those two triangles. So how do you know which triangle we have to take? So here if you observe ACBC, this is triangle ABC, BDAD, triangle ABD. So let's take both the triangles. Triangle ACD is similar to triangle ABC, because both have one angle A is common and 190 degrees. So by AA both will be similar. Now we write similarity properties. AC by AB is equal to, here again AC by AD. So AC by AD is equal to, AC by AB is equal to AD by AC. Similarly, this second part also will be similar to the bigger triangle, that is triangle BDC similar to triangle ABC. So here also we can write BC by AC just a moment, we have taken this combination wrong. So while doing sums like this, we should ensure that the right angle is in the middle. In triangle ACD, at C we have right angle, so ACD, and in ABC right angle placement should be equal. So here at a D right angle is there, similarly here at a C right angle is there. So both are placed at the exact places. So that way we write this. And here again in BCD, at D, at the last point we have right angle, and in BAC we have last point as right angle. So while writing these triangles names, we should be very careful. Once we do that, answer is very simple to obtain. All we need is BC square. So we need to get 2 BCs, and AC square we need to get 2 ACs. So here we can get 2 ACs, because in both the triangles we have AC, and here we can get 2 BCs, because here also we have BC and here also we have BC. So let's try to get them. That is, first target is AC square. So AC, in the place of AC here we have AB, corresponding side is AB. Here again we need AC, so in the place of AC here we have AD. Similarly here we need BC, in the place of BC we have corresponding side BA, and here we need BC, in that place we need BD. So let's multiply. AC square is equal to AB into AD. BC square is equal to BA into BD. So now all we need is divide both the things. AC square by BC square. Sorry, in the answer we need the reverse order. So let's do that. Here BC square by AC square. So BC square by AC square is equal to BA BD by AB and AD. These two are same, BA and AB. So BD, AD will be left out. So that's what we are supposed to prove. Now we are left with example number 14. O is any point inside the right angle. O is any point in the right angle ABCD, and prove that OB square plus OD square is equal to OA square plus OC square. Obviously we need right angle triangle to prove our case. So here by this rectangle they have triangles, but these are not right angle triangles. In order to get right angle triangles, we will do a small construction, that is we draw a small line PQ, means we have draw a line PQ which is parallel to BC as well as AD. So automatically this will be parallel to this, and angle P will be right angle triangle, because when this is parallel to this it must be perpendicular to this. That is what is explained here. So here at P on both sides and here at Q on both sides we have right angle triangles. So by this construction we have 4 right angle triangles, 1 2 3 4. Now all we have to do is we have to apply Pythagoras theorem in these 4 right angle triangles, so that you will get your answer. Now let's see, let's take this first one, that is triangle OPA. Where is right angle P? So the opposite side will be hypotenuse. OA square is equal to AP square plus OP square. Similarly in second triangle, if you observe, OB square is equal to OB is right angle hypotenuse, or OB square is equal to OP square plus BP square. Similarly third triangle, here right angle is there, OD square is equal to OQ square plus QD square. Here in fourth one, OC square is equal to OQ square plus QC square. So now all we need to do is we have to get this OB square plus OD square. So let's take OB square plus OD square. OB square is nothing but, here what we have, OP square plus PB square. Similarly OD square, what we have, OQ square plus QD square. Now all we need to do is we need to get this OA square and OC square in the right side. So OA square means what? AP and OP. So OP already there, we need to get AP. Okay, so what we need, we already have, let's underline. So we have OP and all we need to get is AP square. No problem, we will get that. Similarly, to get the OC square on right side, we need to have OQ and QC. OQ already there, we need QC. Now let's observe what we need. AP. AP is equal to what? In the place of AP we can write DQ. So let's write DQ. Let's search for DQ. We have DQ square. So in the place of DQ square we can write AP square, because that part is also a rectangle. So OP square plus AP square, we got these two. Similarly here we need QC square, and what we have is PB. So PB we can write equal to as QC. So P, in the place of PB you can write QC square plus OQ square. Now QC square plus OQ square is OC square. Similarly that of OP square plus AP square is equal to OA square. So this is what we need to prove. OB square plus OD square is equal to OC square plus OA square. So that's how we have proved. Now moving on to the exercise. these are the sums. So first Roman, what they're asking, whether they are right angle triangle or not. So pick out the biggest side and check if it is equal to the sum of the squares of the other two sides. If it is, then you can write it is right angle triangle. If it is not, you can say it is not a right angle triangle. Now similarly, in the second Roman, we have done so many questions like this. PQR is a triangle and right angle at P. So at P we have right angle QR, and we have PM perpendicular to QR. So we have two triangles here. These two small triangles is perpendicular, similar to the bigger triangle. So we need to get PM square is equal to QM by PM square is equal to QM into MR. So we can take QM and MR, which triangles it is there. QM in this triangle and MR is in this triangle. So we can take this part is similar to this part, and you can prove your answer. Simply you will get PQ by something. So you can try that, you will easily get. Coming to the third question also, it is also a similar fashion. Here it is based on this figure. So here there are three triangles, 1 2, and the bigger triangle itself is 3. So all 1 is similar to 2, 1 is similar to 3, 2 is similar to 3. So because we have proved this while doing Pythagoras theorem, or otherwise you can say one right angle triangle and a common angle will be there by AA. This set of triangles will be similar to each other. So each time when you take and you apply, you will get each of these proofs. You try this. If you have any problem, let me know. I'll explain you in the next video. Coming to this question, ABC is right angle triangle at C, means we have at C right angle ABC. So what we can write, AB square is equal to AC square plus BC square. But here it is isosceles triangle, means these two sides are equal. So in place of AC you can take CB, in place of CB you can take AB. So here AB square is equal to hypotenuse square is equal to AC square plus CB square. Instead of taking these two, are since these two are same, you can take any one. So we are taking AC square plus, in place of BC square also we are taking AC square, so it becomes 2AC square. So this is how we prove fourth question. So fifth question is converse, that is reverse. It is given, the same thing is given, and they are asking, say, like in C, B, they are giving AB square is equal to AC square plus AC square, 2AC square they are giving. So AB square is equal to 2AC square. We can write AC square plus AC square. In place of one AC, since these two sides are equal, we can write AC square plus BC square. So since AB square is equal to AC square plus BC square, this is a right angle triangle. That is what we need to prove here. There isn't anything more. Now coming to the sixth question. Sixth question is equilateral triangle is there. Side is 2A. Find each of its altitudes. So if you find one altitude, it will be sufficient to find other altitudes also. Let's find this in a new page. So this is the setup. This is a right angle triangle. All the three sides are equilateral triangle. All the three sides are equal, and we have this line called altitude. We need to find the length of this altitude. In equilateral triangle, this altitude is a median also. So it cuts the base into two equal parts. So each part is A and A. So you need to find the height that you need to find this AD, let's call. You need to find AD, and we know that triangle ADB is right angle triangle. So simply you will apply right angle triangle, Pythagoras theorem. So what is the bigger side or angle side opposite to biggest angle is AB square is equal to BD square plus AD square. Now AB is 2A, BD is A, AD we don't know, that is what we have to find out. So AD square is equal to, this is 4A square, and this one when it comes here minus A square, 3A square. So AD square, AD is equal to root 3A square. So root 3 into A square here. So this is the height. If side is 2A, altitude will be root 3 into A. It will be useful to us in solving many other sums. So, but in that case, we will take side as A and height as root 3 by 2 A, because it is half of what we have in this particular sum. So it is very important. Now coming to the last question. This prove that the sum of sides of squares of sides of a rhombus is equal to sum of sides of its diagonals. This question we will do in the, I'll give you clue. If you are not able to do, we will do in the next this thing. So simply we have a rhombus here. In this rhombus they're asking us to prove, so we will take these diagonals also. So a, b, c, d, sum of squares of sides, that is ab square plus bc square plus cd square plus ad square. So ab square will be ob square plus oa square, bc square will be ob square plus oc square. Similarly cd square is oc square plus od square. Similarly ad square is oa square plus ab square. If you add all these things, sum of squares of side is equal to sum of squares of its diagonals. It will automatically come. You try it once. If you don't get, we will do it in the next video. That's all.